This is an example of linear regression. This one comes from our textbook, Math in Action. In section 1.10, it's exercise number 2 on page 96. So we're going to look at this example here as an example of linear regression, and it's going to be similar to the linear regression task that you are assigned in project number 7. So the first thing I have done here is I've entered the data in the table for number 2. We have the years since 2011 in the first column for the independent variable. And then we have the number of worldwide PC shipments in the second column for the dependent variable. Now, the first thing that I'm asked to do in this question in the textbook is to plot the data. So I have my table entered here. The plot has already happened, but I just can't see it yet. So I'm going to zoom with the zoom fit icon, this magnifying glass icon right here, so that now I can see the data. So it zooms in over to the data and fits in the appropriate window. So in my book, I can make a quick sketch of these ordered pairs, and I do this sketch to observe that the pattern does seem to be linear. I can see that there would be a nice straight line that would be close to the data, not going through every point, but there is a general linear trend where I have a pretty consistent downward slope or downward decay here. All right. So now that we have our graph, we can sketch that in, and then we want to find the regression equation in part B. To do a regression equation, I know a linear equation is y equals mx plus b. I also know that it's not exact, so I'm going to use the tilde sign for approximate, and I need to match my variables x and y to the table. In this case, my x variable is going to be x1, and my y variable is going to be y1. So I'm going to write y1. And then not equals, but approximately for regression, mx1 to match x1 up here, and then, 1, then plus b. And my regression line graphs automatically, and then I can see the equation for it down here. All right, so if I were writing my book, I would jot down the equation, y equals negative 24.51. I'm going to jot the equation down here as well. Y equals negative 24.057. X plus our b value is 368.843. Right, so that's the equation. That is the regression equation. I find it with this regression statement, which contains the tilde sign, and it contains x1, y1. But when I actually go to write the equation, I use regular x, y, and an equal sign. And you can see that it graphed right on top of the equation that I already had there. Perfect. All right. Now, oftentimes, instead of writing the second line as an equation, we write it in function notation because we can use function notation to evaluate the function for certain variables. So I'm going to go ahead and change that from a y to an f of x. All right. So now on to my next line. In part C of the book question number 2, it asks you what the slope is, what the practical meaning of the slope is. Project 7 is going to ask us as well to interpret the slope. I can see the value right here clearly. It's m equals negative 24.571, I meant to say. So what's important about this piece is not just saying the number, but saying what it means. All right. So I need my units for y. So y is worldwide PC shipments. Sorry, I put that in a note. Otherwise, it is not going to look pretty. Note, there we go. So I'm going to put some words in front of this, but the number of worldwide PC shipments, and then what's it doing is, okay, negative. So is decreasing by how much? Okay, so now I put my value in here, 24.057. I need my units here as well, 20.057. Remember, this is in millions. Million, and then per, I could say million units. Oops, accidentally shrunk that. Million units if I wanted to, because the book does specify that the units here are millions of units, so million units, just to add in an extra word there, per, and then the units on my x variable, so per, that's in years, so per year. Okay. That's exactly what I would like my sentence to contain anytime I describe slope. What is it? What is y? What is it doing? Is it increasing or decreasing? By how much? What are the units on y? And then what are the units on x? Units on Y, this case, were million units, million PC units, and the units on X were years. Please make sure that you have all of those pieces in your explanation of slope. All right. Continuing down to part D, use your regression line to determine the number of PC shipped in 2013. 2013 is 2 years after 2011, so I can take my function that I have already defined here, and I can evaluate it at 2, f of 2. If you're making a prediction, always state your answer in a sentence. So this function predicts that. I'm going to copy just so I don't have to type quite as much. Then, and I gotta put it in a note. The number of worldwide PC shipments in 2013 was, and now I have the value, 320.729 million. I always, if I need to make a prediction, I always need to explain the prediction as well. And usually in the projects, I note that. I note that you need to make this prediction and you need to note text box to explain what it means in context. When you explain what it means in context, you need to explain what the input means. In this case, the input refers to the year 2013, 2 years after 2011, and what the output means. In this case, it's the number of millions of shipments. All right. Part E asks us to use the regression equation to predict the number in 2020. All right, so I know that 2020 is 9 years past 2011. They didn't tell me this time what to plug in for t, but I can compute that. And then I'm going to evaluate my function for an input of 9, since it's still a year value that I'm trying to predict. And then we can have a similar statement down here, keep forgetting my notes, in a note box that says now in 2020, the number of PC shipments was 152.33 million. All right, so very similar prediction right there. Part F, what process was used to make the prediction in part E? And so what they're getting at here is that our table goes up from 2011, 12, 13, 14, 15, 16. So it goes up to 2016. So since 2020 is beyond the edge of the data, this prediction was extrapolation. Okay, so the 2020 prediction was extrapolation because it's beyond the edge of the data set. And that's just important to know when I'm making a prediction. If it's extrapolation, it's just less likely to be reliable. So extrapolation. They didn't ask up here, but since 2 was inside the data point, it's interpolation, and it should be a little more reliable. Although you can see that your second point has a bit more variance from the data set. So this is actual value is a bit higher, 316, than the predicted value of 320. Is this the 2 point? No, that's the 1 point. Sorry, this one. This is the 2 point. There we go. It's a bit lower. I'm going to say that looks higher. This is a bit lower than the actual data point because there is a bit of variance there. Had I predicted for this last point, that's the one that happens to be closest. There will always be variance between the actual value that we predict and then the value that was in the table there. All right, just a few more pieces. The last piece in the book is what is the correlation coefficient? Discuss its meaning. That is given to us by the model, and up here it is a negative 0.9931. So I'm going to make a note of that. So the R value is negative 0.9931. And so what this means is that we have a strong negative correlation. Strong because 0.99 is close to -1. There is a strong negative correlation. Okay, that is all that the question 2 asked me. I'm going to go on to just one additional piece. Sometimes in the projects or in other questions, just not in this one in particular, we're asked to explain the meaning of the intercept, so the x-intercept or the y-intercept. So I'm going to do that here. So our vertical intercept, first, the vertical intercept is 0,368.84. That's also the b value, since the b value is our vertical intercept value. So I'm going to make a quick note of that point. 0,300 and was it 68.34? I can't quite remember. Hopefully that matches. 368. Not 34. 8.84 and 843 if I want to put all the places there. Okay, so that's my point. Just wanted to write it down here so I could see it. And now I want to interpret it. So to interpret it, I need to explain what the 0 coordinate means and what this value means. So since I've already done a few point interpretations, I'm going to copy this one and paste it down here in a note. There we go. And then the year. So in the 0th year, we're actually 0 years since 2011. So we're still in 2011. And then how many PCs were there? There were 368.843 million PC shipments. Okay, so that would be what the vertical intercept would mean. When you interpret a vertical intercept, you still need what does it mean, what's the context behind the situation, and you need to know what the 0 means, so what years it referred to in this case, and what the y coordinate means, that's the number of shipments in this case. And you need the units, of course. Okay, so that would be the vertical intercept's meaning. Sometimes you might even write like something like the vertical intercept means if you want to be extra clear. And then we have our sentence there. Then we're going to go to the horizontal intercept. So I'm going to draft that ordered pair 15.332, 0. And that's way down here. And so we want to, again, explain what that means. So I'm going to copy my sentence in a note and then explain its meaning. So I need to know what the year was and what the number of shipments was. So I'm going to put some space in here and put those numbers in a second. First of all, it's 15.33 years after 2011. So I can calculate 2011 plus 15.33. So that's going to be in the early part of 2026. So I'm going to put that in here now. So in 2026, the number of worldwide shipments, not was anymore, so will be, because we're present tense or future tense instead of past tense. And then how many? The output is the number of shipments, so there will be 0 million shipments. And that's my solution. Now, anytime that you have a prediction that is not likely to be true, you should probably put in a quick note to say so. I didn't do that up above, partially because I don't have very far extrapolation for here, and this was reasonable. We predicted that there were about 368 in 2011. The actual value was 365, very, very close to 368. So that was a very reasonable prediction. So I didn't make a note up there, but this one, it's probably never going to drop to 0, right? And the other part of knowing that it's unlikely is that this is a pretty far extrapolation. It's very far from the edge of the data set. You're more likely to get true predictions close to the edge of the data set, but the further away you get, the less likely they are to be true. So this prediction is unlikely to be true. I'm writing accurate there. This prediction is not likely to be accurate. So just a quick note about that helps me know that you know that you've made a prediction that is the prediction, but is not really an accurate prediction because it's a far extrapolation or it's predicting something that doesn't make sense. Okay, so when you do project 7, you don't need all of these aspects, but you do need some of them. You do need to make a table. You do need to make a regression statement. You do need to interpret slope, and you do need to interpret vertical intercept. Other projects may have the other elements, so I hope this example helps as you're doing your linear regression.